Hello, students. This is Mr. Allen, and today we're going to move to Chapter 12. So last week we started, we did two lessons, but one of the lessons was on Chapter 10, where we built the foundation for circles, talking about radii, diameters, etc., circumference, area. Today we're going to move on, and we're going to look at tangent lines to circles. Our objective here is to use properties of tangent to a circle. So let's make sure we understand what a tangent line is to a circle. And so what I've got here is a diagram, and we can see we have circle O. And the way we would write that, just as a reminder from last week, circle O, we would just call it circle O. So you put a circle with a dot in the middle, that means circle, and then circle O. So we would say that line L, so that's line L, is a tangent to the circle because it intersects the circle at exactly one point. That is what a tangent line is. You probably already know that. Let me give you an example of something that is not a tangent line. This line here, we'll call it line Q. Line Q is not a tangent line. It is what we call a secant line. And I guess there's another possibility too. You could have a line like this here. We'll call that line R. Line R doesn't intersect the circle at all. So it's not a tangent line. It's not a secant line. It's just a line. Okay? So this is the tangent line here. This is the tangent. So theorem 12.1 says, if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So if we look in our diagram here, we can see that we have line AB. Line AB is tangent to circle O. There's that notation, circle O, at point P. So point P right there, that is the point of tangency. If that is indeed a tangent line, then we can conclude line AB is perpendicular to segment OP. In other words, they form a right angle. So this is theorem 12.1. Let's look at an example. This is a multiple choice question. It says segment ML and segment MN are tangent to circle O. What is the value of X? So the first thing that I would notice, or I would tell you to notice, in fact, let me highlight it here. Hopefully we got our highlighter here on yellow, is that this is a quadrilateral. And since it is a quadrilateral, we know that the sum of the angles is 360 degrees. Now, since we know that these two line segments are perpendicular to the circle, we also know that, for example, line or angle L and angle N are right angles. In other words, they have to be 90 degrees and 90 degrees. So now we have all the information that we need to solve this problem. We know that 117 plus 90 plus another 90 plus the measure of angle M is 360. So now I'm going to just take my calculator and I'm just going to start subtracting those values. So minus 117, minus 90, minus 90. And I get that the measure of angle M, which is equal to X, turns out to be, according to my calculations, 63. So our answer is 63. We utilized theorem 12.1, which tells us if these are tangents, they have to be perpendicular at the point of tangency. Example 2, it says the CN Tower in Toronto, Canada, has an observation deck that is 447 meters above ground level. About how far is it from the observation deck to the horizon, if I can say the word horizon? Earth's radius is about 6,400 kilometers. So we've got a couple of things here. Here's a picture of the tower. And one of the key things, I'm going to point this out right now so that I don't make the mistake when I try to explain this to you, is notice that this number is in meters and this number is in kilometers. So we need to go one way or the other. It really doesn't matter. I'll probably, I think I might do this in kilometers, but let's see how it works out. So first thing you might want to do is actually just try to draw some sort of a picture. Okay, so what I've done is I've got this circle here that's going to represent the Earth. We know that the radius, because it tells us that the radius is 6,400 kilometers. So this has to be 6,400 kilometers as well. Now notice that this distance right here, this S to Q, I'm going to let that be this distance here. So that's that. In fact, let me do this in a different color here. Let's do that in red. That's going to be 447 meters. Now, in order to convert that to kilometers, we just got to divide. So let's see here. So 1,000, right? So that's going to be equivalent to so if I did 447 divided by 1,000, that's just going to give me, oh, I guess I should have known that. Just move the decimal. This is it in kilometers. Okay, that's kilometers. I'm trying to put kilometers there. So this total distance from O to Q is 6,400 plus 417 decimal point there. Don't forget the decimal point, which is going to be 6,400.447. Didn't need to erase that there. There we go. There should be a decimal point right here. So that's that distance. We know that OP's length is 6,400 because that's the radius of the Earth. Now we're trying to figure out, here's what the question is asked. The question is they want us essentially to find what is the length of PQ. So we're going to have to do the Pythagorean theorem. In other words, if you guys don't mind, just to make this simpler, I'm going to call this length here x, because we're going to use the Pythagorean theorem since this is a tangent line. Since we're going to the horizon, that means that has to be 90. It satisfies the Pythagorean theorem. So I know that 6,400 squared plus x squared is going to be equal to 6,400.447 squared. And I'm certainly going to use my calculator here. So I'm going to do the 6,400.447 squared minus 6,400 squared. And that gives me 5,721.798. And then I'm just going to square root that. Again, I'm using my calculator. And I get 75.643 kilometers. That is in kilometers. I did my answer in kilometers. That's how far it is from the horizon. Okay. Theorem 12.2. If a line in a plane of a circle is perpendicular to a radius at its endpoints on the circle, then the line is tangent to the circle. So this, is, you can see, is basically the converse. So what this one's saying is if this segment is perpendicular to this line and it touches at point P, then it has to be a tangent. So this is just the converse of 12.1. So let's see how that could work. So here we are told that we have a segment AB that is perpendicular to segment BC, and segment BC is a radius. We know that it's a right angle. So, and I think I said my words there incorrectly. Let me try that again. We've got this segment AB and this segment BC. We know that they're perpendicular at point B. Therefore, so I can automatically conclude, therefore, segment AB is perpendicular to segment BC, and therefore it is a tangent line. That's the key thing. It is a tangent line. All right, so it's not super interesting in this particular example, except now we're just going to have to do the Pythagorean theorem. So again, we've got a right triangle, so we can do the Pythagorean theorem. And so we're going to say that x squared plus 12 squared is going to be equal to x plus 8. Here's where we got to be careful. Squared. All right, so I'm going to move this out of the way. So x squared is just x squared. 12 squared is 144. Now this right-hand side is going to be x squared plus 16x plus 64. So that's a review from Algebra 1. You have to FOIL. You got to take x plus 8 times x plus 8. Notice that on both sides of the equation that the x squares will cancel. So I'll go ahead and go over to here. I'm going to move my picture up here. So I'm going to get 144 equals 16x plus 64. Now I can do 144 minus 64. So that gives me 80 equals 16x. And now I just need to divide 80 by 16. Again, I'm using my calculator, and I get 5. X is 5, so the radius is 5. And that's your answer. All right, so here we go. Is ML tangent to circle N at L? Well, in order for it to be tangent, let's go back to this one right here. In order for it to be tangent, it has to be perpendicular. So now I just need to use the converse of the Pythagorean theorem to see. And if you remember, the converse of the Pythagorean theorem tells us that if a squared plus b squared is equal to c squared, then it's a right triangle. So let's see if it is. So we need to check. Here are our side lengths. So we got, remember, that's going to have to be the hypotenuse because that's the long side. So 25 squared question mark, is that equal to 7 squared plus 24 squared? So again, I got my calculator here. So 25 squared is 625. 7 squared is 49. 24 squared is 576. 49 plus 576 is 625. Those are equal, so yes. ML is tangent to circle N at L by the converse of the Pythagorean theorem. That's our answer. All right, last theorem. If two tangent segments to a circle share a common endpoint on the outside of the circle, then the two segments are congruent. So here's what we're saying. If these two segments, make sure we're on highlighter. If segment BA and segment BC, that's these two segments right here, if they are indeed tangent to that circle, then our conclusion is that they have to be congruent. In other words, this has to be the same distance as this. I'll prove that in class. So we have a circle here, and it's what we call an inscribed circle. So you can see it's kind of like inside the triangle, and it intersects at exactly one point at each of those. So that means that segment AB, segment AC, and segment BC are all tangents. Since they're all tangents, we know that segment AD has to be congruent to segment AF. So AD's measure has to be the same as AF. We also know that FC has to be equal to CE. And again, now let me go a little bit slower on this last one. We also know that DB, this segment right here, has to be congruent with this segment right here. So that means that the length of DB and EB has to be equal. In other words, since AD is 10, then AF is 10. Since FC is 8, then CE is 8. And if DB is 15, then EB is 15. We know all of these things, so now all we got to do is just add all of them together, because this question is asking us for this perimeter, the total distance around. Again, I'm going to use my calculator to make sure I don't make any careless mistakes, and I get a total perimeter of 60 centimeters. The total distance around is 60 centimeters. And that'll end our lesson for today. Thank you for your attention.